Hello everyone, I'm Bee and this is my channel. Today we're going to learn how to create this cute little pet that follows you around forever. We're going to use simple maths, C++ and blueprints. As you can see, the little pet, the little fox, it follows me, always keeping the instance, very important, and when I stop, it will stop with me and it's going to follow with me around forever. Basically, it has a simple blending animation between idle and walk and running, and that's it. So let's do it. For this tutorial, we're gonna need three things: the pet follower, the fox, that's a character blueprint, which is this one, which extends from PetFollower and is a character. We are also going to need an animation blueprint to do the blending between moving and walking and idle. And we're going to use a blend space in 1D to do this blending, this animation blending. So you can see we have the blending between idle, walk and running, and we're gonna use a parameter speed that we're gonna fit on the animation blueprint, which is this one. It simply has this local motion 1D blending space and speed that we're going to use a fit from the pet follower. That's it. And this is the type of pet anim instance, which is an anim instance C++ class, because I want to fit this speed variable through C++ instead of using the blueprint. Let's make first this anim instance and the locomotion blend space. So for this, we're gonna need some type of skeletal mesh, well, some kind of character, something that you have with different animations. I'm gonna link this fox. I took it from a website, so you can get it if you want. It's completely free. This fox comes with a bunch of animation, and I basically took the idle, the run and the walk, and I created the locomotion blend space from there. So I'm going to show you how to do that. So first, right click, animation blend space 1D. Then we need to select the skeleton. In my case, it's the fox skeleton. Then we can open this and you will see this. So all we have to do is first let's get this parameter, which is in this case gonna be a speed. Let's leave this. Let's see what I have here. Okay, I have 300. Let's put the same. Okay, 300 maximum. And all you have to do, if you select the correct skeleton, you will see all the animations here. So let's put here fox idle. Okay, and then right here walk. One. And finally, let's take run. So this is quite handy. This means when the speed is 0, it's going to stop completely. When it's around 75, it's gonna start blending from idle to walk in a smooth transition, and then finally it's gonna go to run, from walk to run. So this is very handy. Let's use that locomotion in fox in the animation blueprint. So right click, animation blueprint, and again we have to select the correct skeleton. In my case, it's fox skeleton. Let's set any name. Okay, anim2, And then you will see that you have this. So all I did was to create a state machine. State machine. Important to default. Okay, now we can go here and create the state. I'm gonna set idle run, and then if we go inside, we can plug the locomotion. So we can just because everything is attached to the same skeleton, you will see that here. The one that we created is this one, so we can just hit this here. And now we didn't need the speed, so this animation blueprint is based on the basic one, so I'm gonna change that for the one I created, which is very basic. I'll show you in a bit how it looks like. So I have pet anim instance, right? And as you can see, as soon as I added that, I had this speed here. If you don't use this C++ class, you will have to create this variable using the variables, and then you will need to do some kind of do that connection through Blueprint. I'd rather do this connection on C++. You will see what I mean in a bit, because it saves a bit of performance. I don't have to create like events or casting or necessary things that I can do on C++. So we can just plug this there. And that's it. That should be it for this part. Let me show you the pet anim instance, which as you can see is the type of EU anim instance. And all it has is a EU property, edit anywhere, blueprint react write, and a category. And with this we can connect this with the next bit, which is the PetFollower character. Let's move on now to the PetFollower, which is the type PetFollower, and it's basically a character. So the way I did this class is basically, okay, I went here, new C++ class, then character, next, and I set the name. I'm not gonna do this because this takes a while, but I had PetFollower. That's the one I have, so yeah, I can set a different name, but it will be that. So as soon as you get that and compile, you will have these elements by default, which is just a standard character base class. And all I did is I selected the mesh fox, and then the anim blueprint that I just created, which in that case it will be anim 2, yes. I'm gonna stick with mine because I like the name better. Oops, yeah. But it's the same, they both are the same. I also did an adjustment on this capsule, so I reduced the size of the height and the radius, and I also adjusted where the static mesh is set. So as you can see, that's the collider, so the fox can collide with other elements. Yeah. And another important thing that I like to do is I usually like to disable the tick until I really need it. You will see what I mean in a bit, but I always have this start with tick enabled at false, unless I know it's gonna have the tick running on the background all the time, but that's not usually the case when I have these type of things. And finally, let me show you on the begin play what I did, which is basically I call this function, which is declared on the PetFollower, and it's simply to send the reference to the controller bound, which in this case is the robot. It will send that with a small delay just in case the robot hasn't been spawned, so I'm just gonna wait a little longer. Probably this is not necessary, but it's just in case. So I'm gonna send that to the StartFollow, and this will trigger the whole thing. So the fox will start following the robot, and it will do a bunch of things. Let's move on now to the PetFollower C++ class. Is an actor character, as a character. And then what we had first is a few editor properties. We have the speed movement, that's the initial speed movement. This is the minimum distance to the actor. In this case, it will be the robot. This is the stop radius. This is the radius where the pet follower is gonna start stopping, and it needs to be greater than this one. You will see why. This is the reference of the actor that is gonna follow. I made it generic, so basically you could use any kind of actor. It doesn't have to be the controller. The player it can be another NPC. And then we have StartFollow, which is the function that you just seen, and StopFollow, which has not been used but is a stop mechanism. Then we have the tick, the begin play, the constructor, and then we have helper elements, and here I have the pet anim instance that I created. This one is a reference to that, so I can use that speed property that we created earlier. Then we have states. I like to use the states for instead of have a bunch of booleans, I like to work with states. So depending on the situation of the pet, I will have one state or the other. And this is finally the last location of the pet. Let's go to the CPP. Constructor, nothing to be seen there. The begin play. On the begin play, again, I set the actor tick enabled to false because I'm not gonna start using the tick unless I have an actor to follow. So imagine you're like, I don't know, super far away from the character, and you don't need really to do anything with this pet until the character enters to a trigger or something like that. Then you can have this as a false, so the tick won't be running there on the background doing nothing. It can go some spikes, some performance. And then when the player enters that trigger and the trigger has a reference to this pet follower, you can then enable the tick and start doing things. Next thing we do is get a reference to the anim instance. We do that with the getMesh, which is one of the elements on the character, the base class. Then we get the getAnim instance, which is gonna be the skeletal, the animation blueprint attached to the mesh. We do a cast because we need that specific. If it's not null, we set the speed to 0. So we just make sure that the pet is gonna start in a stop animation. Then we set the current state to 0, so nothing is gonna happen right now. And finally, the last location is get actor location, just to have that reference because we're gonna use that later. Let's take a look at the StartFollow. As you can see, it will get the reference, and if it's not null, it will change the state to 1 and start the tick. So in my case, as soon as you press play on the game, it will start following right away because I don't have any that logic with the trigger and all of that. But this is handy on that case. StopFollow is just set the state to 0 and the speed to 0. Nothing difficult there. The next part is the tick. So this pet, as you can see, is very basic. It will work well when you are in a flat terrain or flat environment. It will go through some slopes and elements like that, but don't expect to be very, very complex and So it's just a basic pet. If you want to do something more complex, maybe it's better to use Navmesh. But in this case, I thought it was interesting to do something like this with maths. A bit of maths is not very complex, and you don't need to create behaviors and all of that, which can be a bit messy for such a simple thing. I don't recommend this for if you want a pet to follow you around for the whole map, because probably you will encounter problems like obstacles. For example, this pet won't prevent those obstacles, it will get stuck and stuff like that. But for something simple, imagine like a ball that is following you in a small space, it could be useful. Now, on the tick, we use those states. And every time the tick is running, we get the current location. We set this to 0, and we also get the other actor location. Also setting this to 0 because I'm not interested on those. I'm just interested on the X and Y. So on the floor, let's say, and I get the distance between the two of them. Now we're in state 1. That's right when we start following the actor. What we do is we wait until the other actor is like less than 50 in distance. In that case, so this is like a wait state. Don't do anything until the player is close enough. And then I will update the last location and set the current state to 2. And just in case, I'm gonna set the speed to 0. So the pet is not gonna move. When this happens, we go to the current state 2, which is really when we start following the player for good. And here's when we have the heavy maths, but it's quite simple. So this stop radius, it's when it's a distance between the minimum distance to the player and the stop radius. So in my case, it's around, well, it's less than this. I think it's 17 or something like that. So on that case, what we do is we're gonna get like a speed factor, so it will slow down a bit until it's completely 0. For that, we can use this simple function, which is it will do a normalization between two values, minimum and maximum, and it will scale the value to 0 to 1. So we'll take the value distant to actor, and this is the minimum and this is the maximum, and we will multiply that for the current speed, which is the initial speed movement that we set here. Next is to update the position and rotation of the pet based on where is the player. And so I have this if, and I did some tests and this worked for me. You might need to adjust this. But basically, if the speed is more than 5, then we do the location and rotation. And for that, it's very simple. We take the other actor position, which we have here, and then we take the current location, and that's the direction we're gonna follow. It's important to take this vector and make it normalize it, which will give us a length of 1. And we remove the set. This makes things easier in general if you just take 2 of the axes. We have the direction. Now we can get the rotation, and the rotation is we can just get the direction to follow and create a rotator with this function. Very simple. And in this one, I just want the yaw. I don't want to rotate in any other direction, so that's why I have this 0, 0. Now, to make the pet to move, we are going to use the transform of using the direction. So for that, we get again the actor location, the current one. Then we use the speed, which will be a speed movement maybe with that factor, the delta time, and the direction to follow that we just calculated. And the rotation is we're gonna get the current rotation. So we make the actor move, just applying an add, and for the rotation we are going to use this interp 2, which will make things smoother. So this is the current rotation of the actor, and this is the target. So instead of rotating like really like a snap into the other rotation, it will do a nice smooth transition. And finally we set the actor location and rotation using the new location and the current rotation. This third parameter is to make sure that the pet doesn't cross through walls or anything like that. So it will get stuck, but at least it won't go inside elements. And if there are other actor, it will get stuck there. So there will be some kind of collision. If this is too false, it will work in a different way. Next, we get again the distance to the last location with the last location and the current location. And this is just like to stop again, depending on the distance and the delta time. If this is this arbitrary value again, we will set the speed to 0 and move on to the third state, which is just like stop for a while and check what is going on. So this is gonna happen when they are moving very close, and they're very close. So this is a way to check that if they're close, stop. Don't follow the player forever. So it will always keep that minimum distance. And in the state 3, what we do is, okay, so if the distance is more than the stop radius, then let's go back to the current state 2 and we will do the same again. We always apply this speed, so we fit the speed that we calculated here to the animation. So the fox will always move blend between the idle and the walk and the run. Finally, we update the last location. That's the whole C++ class to make this simple, basic, so very basic pet follower. Let's go back to Unreal and let's check those values that I set for the pet. I have speed movement 1000, minimum distance to actor 50, and the stop radius is 70. So this is like the minimum, as the pet is not gonna get closer to this. We can reduce this a little bit, and let's put this to 45. So between these two and these two, it will stop stopping slowly until it reaches 0 completely. Let's try this one more time. So right now the pet has reference to the player, but because we are not close enough, it's not gonna start following the player. As soon as I get closer, but it does that weird thing, but you will see that now it's closer than before, and then it will stop. As soon as I stop, it will stop with me. And that's it. That's the whole tutorial. I think it's useful and it's fun just to have a little guy following you around. That's it for today's tutorial. I hope it was useful, and if you like it, please like, subscribe, it helps. And don't forget to check my game, Kitori Academy, which is ready to release on Steam. It's a cozy live sim where you play as with an apprentice, and you will live your life as a student in an academy and do lots of activities. We just released a trailer for that, so I'm gonna put the trailer somewhere and you can check it out and check the game. And that's it, so see you next time on the next video. Bye!